Today we will study main features or properties of laser beams. First is directionality. Laser beams are highly directional because as they propagate, divergence is very small, and this is due to phase relationship between the waves. Now in this diagram, this A aperture width, and this is the beam, this is axis of the beam, and this is outer edge of the beam. Theta is the angle between outer edge and axis of the beam, and this theta gives the measure of divergence of a beam, and theta is very small for laser beams. Second is intensity. Laser beams are highly intense beams because of very small divergence, and laser can be concentrated in very small areas. So intensity, the laser beams intensity is very high. Third is monochromicity, the important property of laser beams. Laser beams are highly monochromatic because they have very small frequency spread around a central frequency, and the term delta nu upon nu, frequency spread upon central frequency, gives the measure of monochromicity. More is the value of this term, lesser is the monochromicity of the beam. For ordinary light, this term is around 10 raised to power minus 4 of this order, and this order is comparatively a very large value. And for laser light, this delta nu upon nu, this is the delta nu for laser light is around 500 hertz, and light is again taken same 10 raised to power 14 hertz, and this is 10 raised to power minus 12, which is very small. So laser light is highly monochromatic light. And also from this plot between frequency and intensity, this peak is for laser light, and for this the delta nu, the frequency spread is very small, and for ordinary light this delta nu is very large. Hence we can say that laser light is highly monochromatic. Fourth property is coherence. Laser light is highly coherent light, and it is due to high degree of phase relationship and orderness among the photons, and it is of two types: spatial coherence, first type, and a beam is said to possess spatial coherence if its light waves through any 2 points perpendicular to the direction of propagation of light have constant phase difference over a time interval. And second is temporal coherence, and it is related with time. A beam is said to possess temporal coherence if it has a constant phase relationship at a point for a time interval. Say time interval is taken as tau c, and this tau c is called longitudinal coherence time, and it is around 10 raised to power minus 3 second for laser light and 10 raised to power minus 10 second for ordinary light. If c is the speed of light, then we can calculate coherence length, speed of light multiplied by coherence time. There is another relation between delta nu and coherence time. Delta nu is reciprocal to tau c, and we can also say that if with this diagram we can explain temporal coherence, that a light wave for the time which it maintains, it possesses or remains as sinusoidal wave, जितने टाइम के लिए ये साइनोसॉइडल वेव रहती है उस टाइम को बोलते हैं कोहेरेंस टाइम, और फिर उसमें एक जंप आ जाता है या ब्रेक आ जाता है. So this is temporal coherence. Thank you.